ladies and gentlemen.
So let's talk ratios and proportions. So ratios are comparisons between numbers typically involving division. There's a couple of ways to express it. You can express it using words. We can have A to B or something to something else. You can have a colon where you have one quantity colon another quantity. And then most familiar with most people, I would say, would be division, A over B. So it's important that order does matter here. If I'm saying I want the ratio of oranges to apples, oranges has to be the first number and apples has to be the second number. Also keep in mind that you might have ratios where you're comparing a small part of a population to another small part of a population, or a small part of the population to the whole. So keep in mind ratios are going to be a little bit different, a little bit weird, so take everything one step at a time. So our first question here, Kyle invited 8 boys and 2 girls to his birthday party. What was the ratio of girls to boys that were invited? So girls to boys means that we put the girls first, boys second. So if we wanted to use the colon notation, we could do 2 to 8, or we could do 2 divided by 8. Either one of those is perfectly fine. Do keep in mind that we can reduce this. If you can reduce a proportion or a fraction, you do. If you can, you do. So in this case, both numbers are even, so we could write this as 1 to 4 or 1/2. Not 1/2, 1/4. And that's kind of how that works. Proportions. So ratios are fractions, essentially. Proportions are where you have fractions equal to other fractions, ratios equal to ratios. So one common example of that is scaling. So question 2. On a map, 1 inch represents 14 miles. How many inches apart on the same map are 2 towns if they are 35 miles apart? So we have 1 inch is equal to 14 miles. Not in real life, but for our comparison here. So what we can do is we can have 14 miles is equal to 1 inch for our intents and purposes. This should be equal to the miles to inch ratio for the distance. So we have 2 towns that are 35 miles apart, 35 miles. So how many inches? Question mark inches. So once we make sure that we set this up properly, we have miles being compared with miles, inches being compared with inches. We have one comparison being made on the left, one comparison being made on the right. Then we can really forget about the units. We don't need the units at this point. But how do we solve this? We essentially have 14 over 1 is equal to 35 over x. We don't know what that x is. You could leave it as a question mark if you want to. So there's a lot of bad habits that I see teachers teaching their students. One would be cross multiplication. I really don't like teaching that to my students because I don't find that that's generally applicable, and it does confuse students. Something that does make sense is if I have a fraction on one side is equal to a fraction on the other, then flipping those fractions should maintain the equivalence. So let's look at a simpler example to demonstrate what I mean by this. So if I have 6 over 2, that reduces, that's reducible to 3 over 1. You would hopefully agree with me that this is a true statement. If I flip both fractions, so instead of 6 over 2, I have 2 over 6, and then instead of 3 over 1, I have 1 over 3, this is still a true statement. So as long as it's true before, if I flip it, it's true afterwards. There is a caveat here. Do keep in mind that you cannot divide by 0, so you can't use this trick if there is going to be a conflict of interest, if there's going to be some division by 0. I think we're safe here, so we don't necessarily have to worry about that, but do keep that in the back of your mind that you can't use that trick if there would be division by 0. So always just check back to make sure. So If I flip the fraction we had, we would have 1 over 14 is equal to x over 35. Well, I am dividing an unknown quantity by 35. I can undo that by multiplying. So let's multiply both sides by 35. Multiply both sides by 35. And we get 35 over 14, or 35 fourteenths, is equal to x. Is that reducible? Well, 14 is 7 times 2. 35 is 7 times 5. So we can reduce this actually by a factor of 7. So if I reduce the 35 by 7, I get 5. If I reduce the 14 by 7, I get 2. So x is equal to 5/2, or 2.5. And in this case, the unit would be inches. So let's make sure I have that on there. Inches. There we go. If you have any questions, let me know. Otherwise, I'll see you in the next video.